Okay, thank you, everyone. So just make sure that go ahead and sort of follow through. Let me go ahead and start sharing the screen. Okay, so we're going to go over the quiz number 5. Quiz number 5, okay. So this is quiz number 5. So pretty much this one is just the same. So this is just basic so inductor resistor in parallel circuit. Okay, so the first one, the question number 1 is to find the inductive current IL. So you want to do the formula for the current is IL equals V1 divided by XL. Okay, so V1 is 100 volt divided by XL is 4K. Okay, so 100 divided by 4, that would be 25 milliamp. Okay, so the answer is 25 milliamps for IL. Okay, for number 2, resistor current IR. So IR equals V1 divided by R. Okay, so that's 100 volt divided by 2K, 2 kilo ohm, which equal to 50 milliamps. Okay, so IR is 50 milliamps. And then number 3, the total current IT. So IT equal to square root of the quantity IR square plus IL square. And then you substitute that into that formula. So the square root of the quantity 50 milliamp square plus 25 milliamp square. And that should comes up to approximately 55.9 milliamps. Okay, so the I total is 55.9 milliamps. Okay, so anybody have any question?
If we round to 56, is that considered correct?
Yeah, it's acceptable. Like I said, most of these, we have a set range of plus or minus 5%. Okay, so
Thank you.
you are still within 5% range. Okay. All right, so next one, page down, next one. Okay, so, all right, so the total impedance, okay, so total impedance, we can use the formula, we can use the total impedance, ZT equals V1 divided by I total. So that V1 was 100 volt and the IT was from the previous one, which was 55.9 milliamps. Okay, so 100 volt divided by 55.9 milliamps, that yield 1.79 kilo ohm. Okay, so the answer is ZT is 1.79 kilo ohm. Okay, number 4, the phase angle between VT and IT. Okay, since this one is a parallel circuit, so parallel circuit, inductive current lags voltage. So therefore, we should get a negative angle. Okay, so therefore, theta angles is equal to arctangent of the quantity negative IL divided by IR. So we got arctangent of the quantity negative 25 milliamps divided by 50 milliamps equal to negative 26.57 degree. Okay. Any question on that? It's good. Okay. Next one. Okay, let me see. Remove this one just a little bit. Okay. So this still a parallel circuit. Look like this one is an capacitor resistor combination in parallel. Okay, so this one number 6, capacitor current IC. So IC equal to VT divided by your XC. Okay, so therefore IC equal VT divided by XC, or 24 VAC divided by 20 ohm, which equal to 1.2 amp. Okay, so IC is 1.2 amp. Resistor current IR, so IR equal VT divided by R, which is equal to 24 VAC divided by 20 ohms, which equal to 1.2 amps. So IR equals 1.2 amp. All right, so now we got the total current IT. IT equal to the square root of the quantity IR squared plus IC squared, which is equal to square root of the quantity 1.2 amp squared plus 1.2 amp squared. And you take the square root of that. So that come to 1.697 amps. So you can round it to 1.7 amps. That would be close enough. Okay, so I total is 1.697 amp, or like I said, where you can round it up to 1.7, that would be fine. Okay, any question on this one? No? Okay. Any question?
No.
Okay, next one. All right, okay, so now we got the next one. Okay, now they want to know the total impedance ZT. Okay, so ZT equal VT divided by IT. So we know that VT is 24 VAC divided by 1.697 amps. Like I said, 1.7 amps, that's fine. And that should equal to approximately 14.14 ohm. So ZT is equal to 14.14 ohms. So we know that it should be, since it's in parallel, so it should be less than the smallest value here. So this one is 20, this one 20. So approximately less than 20 should be good enough. So 14.14 ohms is correct. Okay, so this one is a parallel circuit and this one is a capacitive, let me see. So this is capacitive circuit, capacitive. Circuit, so therefore this one is going to be current lead voltage. Okay, so that's a capacitive circuit. So the current's going to lead in voltage. So this is going to be a positive angle because the current, we're going to deal with currents in parallel. So the angles equal tangent of arctangent of the quantity IC divided by IR. So arctangent of quantity 1.2 amps divided by 1.2 amps, which equal to 45 degrees. So your angle, your theta is equal 45 degrees. Any question on this one?
Just real quick, out of curiosity, on question 9, I know rarely, if ever, in class do we deal with milliohms, but are you ever in real life concerned with milliohms?
No, because the closest is 0 ohm is the smallest of the smallest that you can go.
Okay, thank you.
Yeah, usually, you know, most even a single wires, the closest you get to is like close to 5 ohms. So you can never go into a milliohms. Okay. All right, so we'll go to the next one. Next one. Okay. All right, so this is a series circuit. So this one is L and C. So so they want to find the net reactant X of the circuit. So X isn't just, we're looking at the reactant. So it's going to be XC minus the XL. Okay, so XC minus XL equals 120 ohms minus 100 ohms. That gives you 20 ohms. So the answer is 20 ohms for the net reactant. Okay, and number 12, total current IT. So IT equal VT divided by X, or the net reactant. 240 volt divided by 20 ohms equal to 12 amps. So I total equal 12 amps. All right, so voltage across inductor VL. So VL equals XL times IT, which equal to 100 ohms times 12 amps equal to 1200 volt. Okay, and VC equals to XC times I total will equal to 120 ohms times 12 amps. That's be 1,440 volt. Okay, so like I said, X is going to be 20 ohms. I total is 12 amps. VL equal to 1200 VAC, and VC equal to 1440 VAC. Okay, any question on this one? No? Okay, next one. All right, so number 15, inductor current, IL. So IL equals VT divided by XL, which equal to 60 volt divided by 30 ohms, which equals to 2 amps. So IL equals 2 amp. So IC equal VT divided by XC, which equal to 60 volt divided by 40 ohms. So that's come to 1.5 amps. So your IC or capacitive current is 1.5 amps. Okay, now we want to do is find the, okay, the next thing we want to do is find the net IX. So IX is just, now IX is going to be IL minus IC. So 2 amps minus 1.5 amps equals 0.5 amps. Okay, so IX equals 0.5 amps. All right, so the next one, number 18, total impedance or net impedance, ZT equal to VT divided by IX. So therefore, it's going to be 60 volt divided by the total current, 0.5 amps, which equal to 120 ohms. So ZT is 120 ohms. All right. Any question on this one? Everyone's good? Okay. So that's pretty much it. Okay, so back to you, Mr. Pham. Thank you.
Okay, thank you, Sam.
You're welcome.
Okay, let me change it. Let's see. Okay, today we try to complete RCL circuitry. Okay, either parallel or serial. Okay, last time we already talking about RCL in series. Okay, for the circuitry either serial or parallel, you cannot solve the problem with both capacitor and the inductor. No way. So that's why you have to come up with the circuitry only, either RL or RC. Okay? You already know the circuitry for serial RC and RL already. So in order to do it, first thing for serial, you understand a IC and IL will be 180 degrees of phase. That means they will be opposite. Okay? So in order to figure out which one will be dominated, the circuitry, by looking for the net reaction, that will be equal either IC minus IL or IL minus IC, depending on which one is bigger. So first thing they want to calculate the net reaction. In this case, you can see I will be, let's say which one, Okay, HL 100 ohm, HC 50 ohm. So the net will be 100 minus 50. H will be equal 50 ohm. Then the circuitry, the new one. Wait a minute. Okay, so we get a new circuitry with inductor and resistor only. Okay, and then they say they want to calculate the impedance. Let's see here. You can see that. Now on this one, sorry, I skipped that. Okay, go back to the series circuitry again. You get IKL 20, IC 60. So IC higher than IKL. Okay, so the net reactant will be 60 minus 20. You get 40. Okay, and capacity higher than inductive. So the circuitry now will be inductive circuitry, capacity circuitry with a new value of inductive will be 40 ohm, and this still will be 30 ohm. So now we're working with a new one, and we go back to RC series circuit. Okay. Okay, let's see. Now, we'll see what they do in calculation. They want to calculate the total impedance. And we already know RC circuitry here. The total will be R squared plus H squared. Okay? And after you get the total impedance, you're able to calculate the total current. That means you can get total 120 VAC divide to 50 ohm total impedance. You get your 0.4 amp. Then, after you get the total current, and you want to calculate the voltage here, okay, or voltage here, you can take IR times I, okay, IC times I, or IL times I. So that's why we calculate the voltage across R, calculate the voltage across C, and calculate the voltage across L. Okay? And finally, they want to calculate the phase angle. That means the difference between the total voltage and the total current. And now, if you cannot remember the formula, I already given to you what? Given to you the formula. You need to download it. Okay? The thing is, sometimes myself either I couldn't memorize it. Okay? So theta equals 10 minus 1 of minus I over R. That means you're working on this circuitry. that given you minus 53.13 degree. So that's RCL series. Do you have any confusion, any question, anything else? Go ahead. Okay, if it's not, we go to the next circuit. Hopefully you guys already done for this circuitry. Okay, I don't get any solution. However, I just quickly go over. In this case, HC50, HL 100. So the net reactant will be 100 minus 50. Okay, that's what to get number one done. You're going to calculate the total impedance. Okay, so basically you can get a new circuitry with 100 ohm and HL 50 ohm. Then you're going to calculate the total impedance, square root of R squared plus H squared. And if you want to calculate the total current, you can take the total voltage divide to the total impedance. You just did calculation. That's what you get IT. Then if you want to calculate the VR, go back to original circuitry. Okay. IT times R, VC, V, IT times XC, VL, IT times XL. And now, if you want to calculate the phase angle difference, okay, and you remember the circuitry for RL circuit, I believe theta will be 10 minus 1 of H over R. Okay, any question on this example? So that looks like easy for you guys now. So the next parallel RCL circuitry. And you understand it for parallel, okay? IL and IC will be 180 degrees our phase. Okay, IC will be leading. So normally, if you're looking at current IL here, okay, that's a branch current. And also IC, that's a branch current. However, the current flow in here, okay, they will be the difference between IC and IL, okay? So that's why in parallel, they say for the combined RCL in parallel, okay? So IH will be the net reacting current can be combined, okay? Using phasor with the IR to obtain the current IT. If IC greater than IL, the circuitry goes to the capacity circuitry. And if IL greater than IC, circuitry goes into the inductive. So you can see that we have to remove one, either L or C, and you going back to RL parallel circuitry or RC parallel circuitry. Okay. Now, easy to do in a calculator, IR, right? You take the total voltage divide R. IL will be a total voltage divide HL. And IC will be the total voltage divide to HC. Okay? So that will be telling you HC or HL, which one is higher. Okay? And after in this circuitry here, okay, and I believe you calculate the IL. Let's see, IL should be a 12 to 4. And IC will be 12. No. HL equal 20. Sorry. So what you get? Divide 20.
Isn't it divided by 2?
0.6, right?
Doesn't that say XL is 2 ohms?
Or 2
It looks like 20, but it's just 2, I think.
Okay. Okay, so thank you. 2 I see 20 divide 6, right?
Shouldn't that be 12 divided by 6?
Yeah, 12. Come on. You get divide to 6. You get 2M, right?
Yes, sir.
Okay, so the I, that means the net current, the difference between IL, IC. So that will be equal IL, IC. So you get 4 M. So that is the first thing you want to do anything. You have to know which will be the current higher. Okay? In this case, inductive current higher than capacity for M. And now you go back to the circuit with R and L. Okay? And the new current IX will be equal for M. And if you want to calculate the new X value of the new circuitry, you take the VT divide IX. That will you get 3 ohm. So that means this circuitry, you can go back to this circuitry this way. You still get the resistor here. nothing to do. Okay, and now you will be get new inductor. So that will be R, and that will be I. Okay, and you don't know the value. However, you know the current here, 4 amp, and you get the total voltage 12 volt. So that's why you can calculate the inductive capacity. I will be VT divided to 4 amp. That's what you get 3 ohm. So basically, I will be 3 ohm. Okay? After you get the current difference, then you need to calculate the new reactive. Okay? Any question on this one? That is a process. You want to do it, you have to be following. Okay? You see that? Now, you can see you get a new circuit, and that will be 3 ohm, and the current I here. Okay? So you calculate that one, we done. IR, IL, IC, II. Okay? And the question is, the net circuitry is capacity or inductive. In this case, they will be inductive. The thing is IL higher than IC. If IC higher than IL, circuitry will be capacity. Okay, and they give the new value for reactant. That means in this case will be 3 ohm. We already calculated. Okay, and now they want to calculate the total current. So you going back to the circuitry RL in parallel. You get IR, you get II. Then you're able to calculate the I total. Square root IR square plus IX square. So if you not remember the formula, going back for RL in parallel, you're able to get the formula. Okay, that will be helping you to calculate the total current of the circuitry. And if you want to calculate the total impedance, then you take the total voltage divide to the total current. And now they're asking you about the phase angle. If you not remember the formula, go back to RL in parallel. They will be telling you what theta equal. Okay, any question? That will be everything we're talking about RCL in series and RCL in parallel. Make sure you understand in order you can do the problem. Okay, so I want you to go ahead and do this example for me. I think that will be uh, the last one. Okay, in order to make sure you understand, then you have to do your calculation. Okay, like I1 IR, IL, IC. Okay, this one is very easy. So that's why normally for the calculation, I given you only 3 minutes maximum. So you can get 24 divided 20.
It's 1.2 amps.
How many?
1.2 amps.
Oh, 1.2. Next one, 24 divided 20. Same
Same.
thing.
Same thing.
And the IC 24 divided 10, right?
2.4 amps.
Okay, 2.4 amp. And now you can calculate right away. Net current will be 2.4 minus 1.2. Is it 1.2, right?
Yes, sir.
And the circuitry will be what?
Capacity.
Capacitive.
Perfect. Capacity. Okay. Now that one capacity. And the new value for the reactant. So the new value, that means you can get I, okay, and they will be equal V total 24 divide 1.2. So what you get?
20 ohms.
20 ohm. Now you can see that they how a little more detail from this original circuitry. You come up with the RC circuit in parallel. And now whatever you want to do calculation, then go to RC circuitry. Then that will be helping you to get whatever you need. Like they say, what they say. They want to calculate the total current and the total impedance. If you want the total current, now they will be equal IR square root IR square, plus IX square. After you get the total current, you can calculate the total impedance. Take the total voltage, divide your total current. And if you can to calculate the phase angle, going back to RC parallel, and you can looking into that formula. then you can see how you calculate it. For my understanding, there will be a 10 minus 1 of I C I over I R. So that's completely done for RCL circuitry in parallel or in series. Okay, and we will be going back on this kind of circuitry using a different way. That means we're using the complex number to solving the same problem, but that is more in the college. Okay, so I still going through it for you, but it's not at this time. I need to go to the filter, passive filter, go to the resonance, and go to the power, AC power. Then we can go invite to take the guide for your knowledge how to solving RCL series parallel circuitry using complex number. Okay, any question? So the next quiz on Wednesday will be covered on RCL series and parallel. So if you understand what needs to be done, then you can get a very good credit. Okay, any question? Okay, if it's not, now I'm going to another subject. That will be, make sure you download it, okay? Let's see. That's the one. Make sure you download it. The decibel. Okay, definition. The decibel unit is important in amplified measurement. So basically, in a real time, you didn't see decibel. However, when you're working on the circuitry, they will be using decibel. And that will be emphasized on the RF radio frequency measurement. So basically in the lab, in the real design anything for the radio signal, transmitter, receiver, they will be using decibel. Okay? The decibel is a measurement of the ratio of one power to another, or one voltage to another, or also one current. Okay? That means the ratio between the output power to the input power. Output voltage to the input voltage, and the output current to the input current. Okay? The power gain is expressed in a decibel, because decibel dB. AP in dB will be equal 10 times log of AP. Okay, just a minute. Okay, so the formula U1AP. AP means power gain. There will be ratio between P out divide P in. That's the basic definition for the power gain. You check the output power divided to input power. You get power gain. And now if you want to do a calculation, AP in dB, decibel, then they're using 10 times log of P out over P in. Okay? Now, if I given you P out, phi watt, okay, to what? I want you to telling me what AP equal and AP in dB equal. Do that calculation for me. So the easy one AP, you can see that phi watt. Divide 2 watt. And now you're telling me what AP in decibel. So you can take 10 times log and you're telling me what they equal. Okay, make sure you have to do a calculation. You can see you can get like we get it. Ah.
9.2.
What do you get?
About 4?
9.2 approximately.
Huh.
Regular gain is 2.5. That's 5 watts divided by the 2 watts.
Yeah, that's okay. But I emphasize the one we be learning. AP in decibel. So that one is easy, right?
3.9. 3.9.
You said 3.9?
Yep.
Okay. That's all right. Okay, so if you not get that answer, bring it up. Otherwise, it's too late, okay? You're learning electronics and you must know about the decibel. Okay, so if you get 3.9 dB, I asking you that one. I get AP equal 0.5. I want AP in dB. Formula will be 10 times log 0.5. What?
Negative 3.01.
Okay, answer will be minus 3 dB. Again, if you not get that answer, please bring it up. We want to clear for everyone. You can use your calculator. You take the log 0.5, then time number 10. Okay? Now, we're talking about voltage. Voltage gain expressed in a decibel will be equal 20 log of AV. They will be different from power. Power will be 10 times. Voltage or the current will be using 20. Okay? So now, if I get VE 10 millivolt, V out 1 volt. I need to calculate the AV. That means V out over V in. And if you want to calculate the dB, AV dB, 20 log of V out over V in. So now the first, what AV equal?
100.
100, correct. AVL, you get a 1 volt. But we in a millivolt, you can take a 1 volt divide to milli. They have to be the same unit. So that 1 volt will be converting to the milli. You get the 1,000 milli divide to 10 milli. And that will be 100. And then in this dB here, the 20 log of 100. See what you get.
40.
40 dB, right?
Yes, right.
For 0 dB. Okay, and the question for the voltage gain in the dB. Okay, one more thing. If I get a V 0.707, I want to know AV in dB. They will be 20 log of 0.707. Then what you get?
-3.
Right, if you're doing a right one, you get minus 3 dB. And one more thing. I get AV0. AV in dB.
Zero. Not exist.
Oh, basically, I want log of 1, sorry. That got to get error.
Okay. Zero.
So what you get?
Zero.
Huh. You say 2, right?
0.
0. Take a log of 1 equal 0 times 20. So the correct will be 0 dB. Okay, now when you say AV equal 1, what that means? How much you understand when you say the voltage gain equal to 1?
V in equal to V out.
Perfect. That means V out equal V in. That means V in is 10 volt, V out 10 volt. They equal. Now, if they equal, that means you're doing a calculation. In the decibel, you get a 0 dB. Okay? 0 dB. That means no loss. Okay? Now, you apply 10 volt, you get 10 volt. That means you not lost anything. However, if you apply 10 volt, you get output only 7 volt. You will get loss. Okay? And if you apply input 5 volt, you get output 10 volt. You get the gain. Okay? So when you're doing a calculation in the decibel, if you get the dB positive, then you get the gain. If you get the dB is negative, you get loss. Okay? However, if you get a 0 dB, that's telling you input, output will be the same, will be no loss. Okay? On the communication between the transmitter and the receiver, only they care about loss. You talking in your cell phone, okay, and go to your friend receiver. If they can get your voice very good, that means no loss. Sometimes storm cause the problem is the voice is not really clear or good. So that means you get lost. Okay. The thing is for communication, they just deal with the lost signal. Okay. Now, the 0 dB reference. Okay. The maximum gain is called a mid-range gain and is assigned to a 0 dB value. So at the mid-range, input-output will be the same. You get no loss. So that's why they be 0 dB. Make sure you understand 0 dB. That means you take the log of number 1. Number 1, that's just telling you input, output will be the same thing. Okay. The next, the critical frequency. Okay. The critical frequency also they get a different name. Make sure you have to know. Otherwise, when they asking you, you don't know what they're talking about. Critical frequency, or they can call a cut-off frequency, or corner frequency, or the break frequency will be the same. Okay? What happened? At this frequency, output power drop to 1/2 of its mid-range. Okay? Now, how much you understand when they say output power drop 1/2 of its mid-range? How many percent? Mid-range means they know lot, right? We already telling you, 0 dB. However, 1/2 will be what? 0.5, right?
5, yeah.
0.5 of the power loss. That at that frequency, okay, will be called cutoff frequency, corner frequency, or break frequency. And you already know we already doing calculation for you. AP equal minus 3 dB. How come? We already did AP equal 10 log of 0.5 for the power. 10 and the question is how come 0.5? The thing is they say 1/2. Okay? Mid-range means no lot, in and out the same. Okay? But if they drop 1/2, that means they drop 0.5. And you're using formula 10 log 0.5. That will be 3 minus 3 dB. Okay? Also, at the critical frequency, the output voltage will be dropped to 70.7% of the mid-range. Okay? If the output supposed to be 10 volt, and now they will be dropped 70.7%. That means 70.7 times 10 divided 100. Okay? That means they drop 7.07 volt. And if you're doing a calculation, and AV for the dB of 0.707, also you get minus 3 dB. Okay, so basically, either for the power gain or voltage gain, at a certain frequency, that's what they call a cutoff frequency, corner frequency, break frequency. Make sure you understand at that frequency, the power will be dropped 1/2. Okay, that means 10 times log of 0.5. Then you get minus 3 dB. Also, if applied for the voltage gain, and the voltage gain will be also dropped but they dropped 70.7% of the mid-range. That means 0.707. And if you take the decibel for the voltage gate, 20 log, 0.707, you get minus 3 dB. So at the minus 3 dB, okay, the frequency at that point is called a critical frequency. Okay, now next one, dBm, power measurement. A unit that is often measuring in power is the dBm. That will be just telling you, you're working on the circuitry using the equipment. When you measure the power, they given you unit dBm. Okay, like you're working normally in the sine wave. Okay, and they unit they can be get you V peak, peak to peak, or VIMN. Okay, however, the unit will be using measuring power. They're using dBm. Outside, you cannot see any dBm. On the power, you measure what you get. You can get the watt, milliwatt, kilowatt, okay? But you not get dBm. dBm only happen while you're working in the circuitry or in the lab for communication, okay? Then they said the term dBm means decibel reference to 1 milliwatt of power. Okay, that means 1 milliwatt in the power will be same thing in the dBm. When dBm is yield, all power measurements are relative to a reference level of 1 milliwatt. These are very important to you. Okay, and I go over that thing. Okay, I try to say get an example in here. Okay, if you get P out, find what? They asking for what is the dBm. Okay, by definition, dBm equal what? 10 times log right here. 10 log of the power P over 1 milliwatt. P can be P in, power in, or power out. Doesn't matter. But if they, in this example, they given you P out 5 watt, and they want it to be in equivalent in the dBm. So that you have to using the formula. dBm equal 10 times log. Okay. So basically, you can see 10 log of P. P they give you 5 watt over 1 milliwatt. And now you can do calculation. Can you tell me what you get? Who can get the answer?
37.
Okay, 36.9, right? 37. If you do it, you get 36.9 or 37 dBm. It's correct. If it's not, bring it up. Anyone in the meeting, you spend the time here. I really want your guy must be understanding what's going on. Okay? That will be help a lot. For your job also, for your future, you keep going up. Again, I want to make sure you understand. You cannot divide 5 watt to milliwatt. They have to be the same unit. So 5 watts here, you must change to milliwatt. Okay? 5,000 milliwatt divide 1 milliwatt. You take the log, then you times 10. Okay? And now I can give you one more here. You get P equal 100 milliwatt. And they want to know, okay, what the dBm. So same thing, 10 times log of 100 milliwatt divide 1 milliwatt. So what you think you get?
$20.
What you get?
20.
D, 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 F. So basically, if you get the power in watt, milliwatt, kilowatt, if they want it equivalent in the dBm, then you know how to do the calculation. So any question on this part here? Okay, if it's not, now we go the other way. Okay, given 33 dBm. We want that to be in watt or milliwatt. So now you're working in the lab. You get power equal 33 dBm. However, we not deal with the dBm outside. We deal with the watt or milliwatt, microwatt. So that's why you have to convert it dBm back into the watt or milliwatt or kilowatt. How can we do? First thing, you must remember the formula dBm. Equal 10 log of P 1 milliwatt. This is the formula given on the first page. Okay? And now that power they given to you, 33. So they will be equal 33 dBm. Can you follow up to this point? They given the power 33 dBm. That's what you're working in the lab. You're working on the circuitry. You get a dBm. However, when you want to do anything else, you have to come up with a watt or milliwatt or kilowatt. Outside, they not deal with the dBm. So the first thing, again, the formula for dBm will be 10 times log of power. Input power, output power doesn't matter. Must be divided by 1 milliwatt. In this case, it is equal 33 dBm. Now, I want log only. Of P over 1 milliwatt equal 33 divide 10 equal 3.3. Okay, you get up to that one. You get that? Now the next anti-lock. I don't want lock anymore.
Anti-lock.
So I take the lock out. You get P 1 milliwatt. Okay, so this will be a log 10. So that will be 10 power 3.3. What you get?
Two watts.
See. What you get?
About 2000 milliwatts.
Is it I get that will be equal 1.99? Correct or not? 10 to the power,
Correct, correct.
10 to the power of 3.3. So that will be telling you P equal 1 milliwatt times 1.99. Look like Joule. Is it you get the same answer with me?
Yes, 2.
Okay, that's perfect.
It should be 2 watts, not 2 milliwatts.
How come you get to what?
By calculation.
You say right here. P, oh shoot, man. P over 1 milliwatt. Okay, equal 1.99.
Milliwatt.
So this what that means. P equal milliwatt, 1 milliwatt times 1.99. So you get 2 milliwatt. How come you can get a watt? Okay, Okay, now you do this for me. Okay, see how you can get that for me. Now they've given you 45 dBm. They want to know that to be in the watt, milliwatt, or kilowatt. Doesn't matter. But that's the unit of the power. So again, you understand dBm. Keep writing down more and more. Then you can remember the formula. 10 times log of P over 1 milliwatt. In this case, they equal 45 dBm. So I want log only. Equal 45 to 10. Okay, anti-log, remove the log. Ten to the power 4.5. I just want to know what P equal. You give me the answer.
31.6.
Can you tell me again?
31.6 milliwatt.
21,
Yeah.
21 what?
31.6 watts.
30 watt. 30.
31.6
31.
watts.
You said 31. 31, right?
3
Yes.
watt, yeah.
31.6 watt or milliwatt.
Milliwatt.
Watts.
Uh-oh.
10 to, you can calculate 10 to power 4 is 10,000.
Okay. 10 to the power 4.5. Okay. They will be 31,623. Thirty-one, 6, 2, 3. Okay. So P will be equal 1 milliwatt time to that number. Okay, they will be equal 1 milliwatt times 31, 6 to 3. Okay. So basically, you get 31, 6, 23 milliwatt or 31.6 watt. That is the right answer.
Sir, the question before also it should be watts, not milliwatts.
The final answer, 31.6 watt. You doing calculation to get 31,623 milliwatt. You divide to 1,000, you get a watt. Okay, you get any question up to this point? If it's not, I will be stopping here, okay? We'll be continuing on Wednesday. Okay, so good night, everyone.
Thank you, Mr.
Good
Pham.
night. Good night.
Good night.
Bye.
Good night.
Bye, everybody.
Bye.